Alright, hello everyone. Today we're going to do some examples about the alcohol mechanisms that we covered in class. So let's start with some of the SN1 reactions, then the SN2 reactions that include alcohol. So first, let's say we have this. Alright, so they gave us an alcohol which is right here, that is a tertiary alcohol. What that means, it means it's on a carbon that is attached to 3 different carbons. So when we have something like this, we know that if we're talking about a tertiary alcohol or tertiary leaving group in general, then it is going to be SN1, not SN2. But if this alcohol was a primary alcohol, then we would say we're going to go with SN2. So let's start with this one first. Whenever I have something like this, like HCl, and I'm adding water to it, the ions are going to be by themselves in the solution. So instead of this, I'm going to have something like this. Instead of having HCl, I'm going to have H plus and Cl minus, because water is going to ionize the HCl. So now I have this. We all know that the alcohol right here, the oxygen right here has the lone pairs, and those lone pairs are going to go and take this hydrogen. So when they take the hydrogen, I'm going to form water at the end. So now that I formed water, now I have a positive charge because my oxygen now has 3 bonds instead of 2. And whenever oxygen has 3 bonds, it's always going to have a positive charge on it. And this is just a quick reminder that we all know that water is neutral. Oxygen has 2 bonds, it's neutral. If I add another bond to it, my oxygen is going to become positive. What if I take a bond off? Just instead of H2O, just 1 hydrogen and 1 oxygen. That's my OH minus. So water is neutral. Oxygen with 2 bonds is neutral. With 3 bonds it's positive. With 1 bond only is negative. And in this case right here, I took a hydrogen and added it to an OH, which was already bonded to a carbon. So I made the oxygen bond with 3 elements or 3 atoms, and that's why it's a positive charge right now. Alright. So since this mechanism is an SN1 mechanism, we know that a leaving group will just leave by itself without any nucleophilic attack. So this is just going to leave by itself, and we're going to form a cation right here. And we're going to have water. But again, we still have the Cl minus in our solution, which was this one right here. So the minus is going to attack the positive, and we're going to end up with this. And this is the mechanism that you guys need to know. That's it. So notice how we started the tertiary alcohol, and if I want to take that alcohol, because I know alcohol is a bad leaving group, I can add HCl, which can dissociate into hydrogen and chlorine. When I put it in water, now I can make this OH into water, make it good leaving group, let it go. Then I can replace the OH with a Cl. And this is the overall mechanism. Right, let's do another example. This time let's do something that is SN2 instead of SN1. So here we go. This time we have a primary alcohol instead of a tertiary alcohol. And we have the same thing, HCl, the H2O. So in this case, again, the HCl, whenever I put it in water, is going to become H plus and Cl minus. The OH goes and take the hydrogen again. I'm going to form this. The only thing in this case, since this is an SN2 reaction, the leaving group will not leave by itself. I need the Cl minus to attack first. Do you guys remember in SN2 we do not form cations? The Cl is going to attack first, then the water is going to leave. I'm going to end up with the same result again. With this, so the Cl replaced the OH, but in this case the leaving group did not leave by itself. The Cl minus had to attack first, and the Cl left. I want to do one more example. Let's say in this case, which we have not covered in class yet, but so far we've been doing every single example with acids. What if I tell you in this case I have a base? It can be anything. Let's say it is NaH. And in the bottom here, this is my one. The bottom I have this group. Alright, so how can I go about this question? So what everyone gets to know about bases, all they do is they sit there and they steal hydrogens. So this is the base, which is NaH. This NaH sees a hydrogen, which is right here. What it's going to do, it's going to take that hydrogen. And when that happens, I'm going to end up with something like this. And now since oxygen only has one bond, again, do you guys remember? It's going to be negatively charged. And to show the full mechanism, I'm going to erase this. And just make a bond between the oxygen and the hydrogen and show how we lost that bond. So the base is going to take the hydrogen, and that one bond is going to go and form a lone pair on the oxygen. That's where we got this extra lone pair right here. Now that we have this, and we have this right here, take a second and think what's going to happen next. The minus charge is going to attack this carbon, and the leaving group is going to leave. So I'm going to end up with something like this, an oxygen, and all I'm adding is a bond between the oxygen and this carbon. So it's going to be my bond, and then I have this that was at the end. So this one right here is this one right here, and this bond that is forming between the oxygen and the carbon is this one right here. So this is just a quick example about bases. If I have an alcohol and a base, how does it react? How does it work? And this is an example for it. So those are all the examples that we did today. The first one is an alcohol and an acid, but with an SN1 reaction. The second one is the same thing, alcohol with an acid but an SN2 reaction. And the third one is an example of alcohol in a basic solution. Hope this was helpful, and I will see you guys next time.